Hi, class. Welcome to our fourth week of home learning. So we're going to keep going with solving equations this week, but now it's changed a little bit because last week we only had one variable that was appearing in our equation. Okay, so this week we're going to have variables appearing on both sides of the equation. That's fine. We can figure out how to do this, so let's try it. And what we're going to see this week is we're going to use these little pictures to help us as we're starting out so that we can see how the algebraic form, okay, the equation we can see written out like this, is connected to something real, right? Because variables aren't just random letters written there. They're representing something. We just don't always know what it is. So when we write our own equations to represent a situation, that's when we know what the variable means. Here we're not sure, but that's okay. We can just use a block to represent it. Okay, so if we look at this to start out, Tracy has to solve the equation 4a plus 6 equals 7a. So how are we going to do this with these balance scales? Okay, so it looks like Tracy is using little blue squares to represent A's. Okay, so those are all A. So we have 4 A's there. A. We have 7 A's on the other side. So we have 4A plus 6 equals 7A. So these little green balls must be our ones. So we have 1, 2, 3, 4, 5, 6. So on this side, we have 4A plus 6. On this side, we have 7A, and you can see that they're equal, right? We can see that they're equal. So let's see what we're going to do with that. Anything? Oh, no. Okay, so if I was going to figure this out, what could I do with that? How would that help me figure out what A is equal to? Because when we're trying to solve an equation, we're trying to figure out what is the value of that variable in this situation, right? So I'll show you with another example on the next page, but we're going to start with that idea that we can represent one whole side of the equation as one side of the balance and the other side of the equation as the other side of the balance. And we know that those are balanced. Those are equal to one another. That's going to help us. So look at the next page. We're going to try to figure out A equals what? So what's A equal to in this equation where we have 5A plus 7 equals 2A plus 1. Okay, so what I did to start out is I put in some symbols here. Okay, so you can see I have 5 hearts on this side, excuse me, and 2 hearts on this side. Why? Well, my hearts must be A's, right? Because I have 5 A's and 2 A's. 5A plus 1, 2, 3, 4, 5, 6, 7 stars. Those are my ones. So 5A plus 7. This would be one side of my balance equals 2A plus 1. This would be the other side of my balance. Okay, so if I wanted to figure out how much is one heart equal to, I have to get all the hearts just on one side of that balance and then just numbers on the other side. So how would I even start doing that? How would I start doing that? I have 5 hearts here, 2 hearts there. Okay, well, I could take away 1 heart from this side. Oops. I could take away 1 heart from this side. But remember, this side's equal to this side, so I have to take away 1 heart from that side. Get rid of that. I'll take away another one. And another one. And I could take away, and I can take away 1 star. I drew in a little scale there just to show us that those are equal. And I'll take away 1 star here. So now I have a bunch of stuff, actually, 3A plus 1, 2, 3, 4, 5, 6 equals nothing, equals 0. This equals 0. Okay, well, we'll put a 0 there just to hold our spot. So what I want is just hearts over here and just stars over here, but I don't have that. I do have these 6 stars, though. So what I can do is I can say, you know what? If I take away 6 stars from this side, okay, if I take away, if I take away 6 stars, okay, take away 6 stars from this side, I can do the same thing on this side. So if I take them all away here, they're just going to be gone. But if I take them away over here, maybe they'll just change color. So instead of yellow stars, we're going to have red stars. Okay, so say I take all these stars and I move them over here. And I'm going to, when they move over here, something's going to happen. Because if I just put them over here like that, those are still positive stars, not negative stars. And they have to be negative because I'm going to add negative 6 stars to both sides. So we'll change these guys to a different color. Ew, that's not a very nice color, is it? Oh, well. We'll just change them all to, oops. Okay, so I changed them all to the negative color. So I had those yellow stars over here. I took away 6 of them. So I took away 6 stars, or I added 6 negative stars, and then a positive star and a negative star make nothing. So the stars are all gone from my left side, and now here they are over here, but they're negative now because I added negative 6 stars. So we don't really need that 0 over there anymore, do we? Because it's not 0 anymore, it's negative 6 stars. So we have 3 hearts equals negative 6 stars. So if I look at the 3 groups, 1, 2, 3, each group fits with a heart. Okay, so if I look and I say 1 heart is the same as 2 stars. And what kind of stars are they? Well, they're negative stars, right? And then this heart goes with these guys. And this heart goes with those guys. So we know that 1 heart equals negative 2 stars. And remember, our hearts were A's, so we could say A equals negative 2. Let's look at another one. Here we go. So use a model or strategy of your choice. Okay, well, I'm going to choose for you. So 5a plus 7 equals 2a plus 1. Okay, so let's take 1, 2, 3, 4. Okay, so you can see I moved them all over there. I have 1, 2, 3, 4, 5a plus 1, 2, 3, 4, 5, 6, 7. So there's 5a plus 7. And on the right, we have 2 a's and 1. 2a plus 1. So what can I do here? Okay, well, I can start taking things away on both sides. Okay, so I'm going to take away that 1. Take away 1 from there. If I do it to one side, I do it to the other side. Okay, all I have left are a's. Take away 1 of those. 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 Okay, so now I'm in that situation like I was before, where I have a bunch of a's here and a bunch of 1s here and nothing over there. Okay, 0. So that means all of this is equal to 0, right? So let's take all our green guys and move them over here, but we'll make them negative, right? So take them away, subtract them from both sides. So when I subtract them from 0, they're going to be negative 1, 2, 3, 4, 5, 6 balls. Okay, little green balls. Those are negative now. We'll just put, look, let's say, these are all negative. Okay, so we have 3 a's equals negative 6. So each a is equal to 1, 2, 1, 2, 1, 2. There's 3 groups. 1, there's 2 groups, there's 3 groups, and each group has negative 2. So that's the same thing we found over here, that a equals negative 2. Okay, just another way to look at it with these balances. Okay, so let's try another one. We have 6x plus 2 equals 10 plus 4x. So let's start by, I'm going to make a little picture to show what that might look like. No, I lied. I'm not going to draw a picture because there is a picture for us this time. Okay, so 6x plus 2 equals 10 plus 4x. So let's take a look. if we drew our little picture, which they've done here, we wrote 1, 2, 3, 4, 5, 6 X's and 2 greens. And then on the other side, we have 4 X's and 10 greens, right? 4 X's and 10 ones. So there's our balance. So what are we going to do? We're going to start taking things away from both sides. Take away a bunch of stuff we can do from both sides. So let's see what they show us down here. It says remove 4 X masses from each pan. Okay, so we're going to take away 4 of those because there's 4 to take away here too. So like get rid of those. Get rid of those. Okay, so what is left? We have 2 X's and 2. Okay, 2x plus 2 on this side, and on this side we still have all our green balls, so there's still 10 there. So we have 2x plus 2 on one side equals, right, the balance, 10. Okay, that's what's left. That's what we just did, so that's how it would look algebraically. 2x plus 2 equals 10. Once we see it that way, hey, we know how to solve that, don't we? Because we just did a whole bunch of those last week. But let's see what it's going to show us here. Okay, well, we can take away our ones. We have 2 ones over here, so we can get rid of those and then take 2 ones away from that side. And that leaves us with 2x equals 1, 2, 3, 4, 5, 6, 7, 8. 2x equals 8. Okay. Well, if 2x equals 8, then I need to have 2 equal groups on this side for each of those x's, because those x's are equal, right? X and x are the same value. So take my 8, split it up into 2 groups, or divide it by 2, and we end up with x equals 4. Each group over here, each of the 2 equal groups is equal to 4. Okay, and then we can check that to see if it's right. We can go back to our original equation. Remember, we had 6x plus 2 equals 10 plus 4x. So that's where this is coming from and this is coming from. Okay, so our left side of our equation was 6x plus 2. And we said, oh, we think x is 4. So let's substitute that in for x. 6 times 4, 24, plus 2 is 26. Okay, let's leave that for a minute. Go to the other side of our equation, which was 10 plus 4x. So that means 10 plus 4 times x. And here we're going to substitute the 4 in for x. So we have 10 plus 4 times 4. Order of operations, you got to do that multiplication first. 10 plus 16. 10 plus 16 is 26. So because the left side is equal to the right side, we know that x equals 4 was correct. You're ready for week 4.